Good morning, students. Today I am going to start the revision for CBSE Board exam. Okay, you listen very carefully. I am going to start the first chapter. Right? If you have any query, write in the chat box. I will respond. Okay, now I will continue the class up to 12:30. Okay, 1 hour I will take the class. If you have any query, write in the chat box. Right, our chapter name is the electric charges and fields. This is our chapter name. First chapter I am going to revise. Okay, first chapter is electric charges and fields. Electric charges and fields. This is our name, and that I am going to revise. And first of all, what is a Coulomb's law? Coulomb's law is what? Whether the writing is clear or is there any required to increase the size? Okay, any problem you can write in the chat box. Okay, now what is Coulomb's law? You know very well, right? If two charges are there, there are q1 and q2 are the two charges. Then between any two charges, either like charges or unlike charges, there is some force is there. That force formula is given by the Coulomb scientist. That force formula is directly proportional to the product of directly proportional to the product of charges, and force inversely proportional to the square of distance between the charges. When we combine both of them, we will get the force proportional to q1 q2 by r square. When the proportionality is removed, we will get a constant, that is uh, 1 by 4 pi epsilon naught into q1 q2 by r square. This is the formula that we will use when the two charges are placed in free space or vacuum. What is the epsilon naught at here? Epsilon naught is the permittivity of a free space. Is the permittivity of free space. What is the permittivity of free space or vacuum? Okay, I will tell you, listen very carefully. The epsilon naught value is 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. This is the epsilon naught value you should remember. If you write the 1 by 4 pi epsilon naught, that also has the value you should remember, that is the 9 into 10 to the power of 9. This formula, equation 1, okay, this is useful when the equation 1, okay, equation 1 is useful when the two charges are in between, two charges are placed in the vacuum. Equation 1 is used. Some are writing the epsilon naught like E naught. Epsilon naught you should write like this, or like this you should write. Okay, you write like this. You write like this, epsilon naught. This is epsilon naught. Epsilon. Now it is not like E. You should not write like E. Okay, remember it. Epsilon naught is the permittivity of free space. Equation 1 is used to find force between charges. Force between charges in vacuum or free space. Vacuum or free space. Okay, if charges are kept in the medium, then what is the formula? For example, the two charges are placed in certain medium whose dielectric constant, for example, we are keeping two charges in the glass. Okay, this is a glass, and the two charges are placed in the glass. They are separated by some distance. Now the force formula, this glass has some dielectric constant. Force formula in the medium, force in medium. Okay, force in free space, this formula. Force in free space, this one. Here F is the force in free space means two charges are in vacuum or free space, then that is the formula. If the two charges are placed in the medium, the force in medium formula is 1 by 4 pi k epsilon naught into q1 q2 by r square. That means same formula extra you will get k, where k is called as the dielectric constant, where k is called as dielectric constant. Okay, right. That means what is the relation between the force in the medium and force in free space? If you want the force in the medium, that is equal to that 1 by except k remaining is the force in free space. There is a force in medium by force in medium is equal to force in free space by k, where k is the dielectric constant. Dielectric constant. This is about Coulomb's law. Okay, right. What is the formula for the force between the two charges in free space? What is the formula for the force between two charges in the medium? And what is the relation between the force in medium and force in free space? Okay, right. Any doubt? Writing size should be increased. Okay, Lakshmi, I will increase. Okay, right. Now, till now we completed something. Is there any query regarding this? Okay, I'm going to erase. If you want, you take screenshot. Okay, right. Next, let us go for the continuation. Next topic is okay. I increase the size. Okay, now I'm going to explain the electric field formula. What is electric field? Electric field means what? It is the region around the electric charge in which its influences exist. Okay, electric field means it is the region. It is the region around the electric charge in which its effect is exist. The charge effect exists up to certain region. That region is called as the electric field. The space around the charge, the space around the charge in which its effect is exist. Its effect charge effect exists up to certain region. That region is called as the space around the charge in which its effect is exist. Effect is present. That is called as electric field. Okay, right. Then what is electric field intensity? Electric field strength can be measured by using a quantity that is called as the electric field intensity. Next term is the electric field intensity. What is electric field intensity? Electric field intensity. Electric field intensity is noted with capital E. It is the strength of the electric field. Okay, right. I will tell you, remember very carefully. It is the force experienced per unit test charge. Okay, force experienced per unit test charge. 1 unit test charge, how much force experience? That is called as electric field intensity. Okay, electric field intensity formula is force by charge. That is the formula for the electric field intensity, equal to F by Q, Q naught, where Q naught is called as the test charge. Q naught is called as test charge. It is used to know the presence of electric field. For example, electric field is indicated like this. For example, this is the electric field. Okay, this is electric field. For example, the electric field is right side. Here I am keeping the some charge for the test to know the electric field. There is a Q naught charge. On this Q naught charge, there is a some force. That force is said to be okay, force on the test charge. That force per unit charge. If 1 coulomb charge, if you keep it here, then how much force acts? That is called the electric field intensity. Now, Electric field intensity unit is Newton per Coulomb, force by charge. Okay, right. Force experienced per unit test charge is called as the electric field intensity. Okay, and next, force on a charge. For example, one charge, force on a charge Q naught. Q naught charge we are keeping in the electric field. Force on a charge Q naught in electric field of intensity E. I am placing one Q naught charge in the electric field. How much force act on that? The force formula is E Q naught. Okay. If you place Q naught charge in the electric field, how much force act on that? From this only, electric field intensity equal to F by Q naught, then from that F equal to E Q naught we write. If you have any query, you write in the chat box. I'm going to erase this. Next topic is the important topic, electric field due to point charge. Electric field due to point charge, or the electric field intensity due to point charge. How to derive this formula? For example, this is a Q charge. Q is the source charge. Q is the source charge. From the Q charge at a point P, I want to find out the electric field. Because this Q charge, around the Q charge, electric field will be produced. The electric field intensity formula, strength formula, I am going to derive it here. Then from the Q charge, due to the point charge Q, okay, this is a Q is a point charge. Q is a point source charge. Point source charge. Due to that charge, I want to find out the electric field at a distance R. Then for that, what you have to do it here, okay, from the Q charge at a distance R, I want to find out the electric field. For that, you should do something, that is, I will tell, okay, you remember very carefully. Then you have to place some test charge at here to test the electric field produced by the Q charge. Q charge produces the electric field because it is a source charge, it can generate the electric field. To know the electric field, we should keep something at here, some charge, some other charge. That charge will experiences the force, right? Then here we will draw one more diagram at here. This is a Q charge here. At R distance, I want to find out the electric field. For that, at the R distance, you should keep one more charge, that is Q naught. Here this Q naught will experiences the some force, right? This Q naught is called as the test charge. Q naught is called as test charge. Thus, the test charge is useful to find out the electric field intensity at point P. That's all. Is no other use. Okay, remember it. And how to find out this? Electric field intensity formula is what? Electric field. Electric field at a distance. At a distance R from small q charge. Okay, electric field at a distance smaller from q charge. I want to find out. Electric field basic formula is force by test charge. What is the force on the q naught charge? 1 by 4 pi epsilon naught into q naught by r square. You know that force formula, right? Force formula, force between two charges according to Coulomb's law. 1 by 4 pi epsilon naught into q1, q2. This is epsilon naught. Remember it. You should write like this. Okay. I will write clearly otherwise. 1 by 4 pi epsilon naught into q1, q2 by r square by q naught. Then electric field intensity formula we will get is 1 by 4 pi epsilon naught into q by r square. This is the formula for the electric field due to point charge. Electric field due to point charge. Okay. This electric field on what factors it depends? Electric field depends upon the source charge, and electric field also depends upon the distance, right? These are the factors on which the electric field depends. How, what is the direction of the electric field? Whether electric field is a vector or scalar. Electric field is a vector. Okay. Source charge is more. Electric field is independent of test charge. Remember it. Electric field is independent of test charge. Electric field is independent of test charge. This is the derivation. Very simple derivation. Okay. Right. Let us go for the continuation. I am going to erase. Okay. Right. Some note important points regarding the electric field I will give. Okay. Right. Now, what is the if Q charge? Electric field intensity. Electric field intensity due to a charge Q. Okay. Due to point charge. What is the formula for the electric field intensity due to point charge Q? Okay. Right. From Q charge at a distance R, if you want the electric field formula is just now we derived, that is 1 by 4 pi epsilon naught into Q by R square. This is the formula for the electric field due to point charge. Okay, right. And next, if source charge is more, electric field is more. If distance is more, if you go away from the charge, electric field will be decreases. Electric field is nothing but force per unit charge. If you place +1 coulomb charge at here, then how much force acts? The force per unit positive charge is called as electric field. But electric field is a vector. Electric field is a vector. Electric field is a vector. Okay, is a vector. Electric field definition is what? E is a vector, its direction is what? Okay. E is, remember it, this is a Q charge. If the distance R you want the electric field direction, for example. If it is positive charge, here you should keep +1 coulomb charge at here. This force on +1 coulomb charge is called as electric field. Okay, this plus Q applies some force at this, it will repels, this side force will act. This force direction only electric field direction. Okay, electric field is equal to force. And now that means electric field अभी स्टार्ट हो गया 12th क्लास और 45 मिनट्स लगेगा remember it, electric field is a vector. What is the direction of the electric field? How to write the electric field direction? That is electric field direction. Electric field is E is away from positive charge. Okay, away from positive charge. How I know that away from positive charge? Radially away from positive charge. Electric field. And electric field is radially towards negative charge. Towards negative charge. If minus q charge is there, for example, this is a minus q charge. At a distance r, if you want to know the electric field direction, the electric field direction is that is towards the negative charge. This is electric field is away from the positive charge and towards the negative charge. This is about the direction of electric field and electric field intensity and electric field due to point charge. The next topic is, I am going to erase this. Electric field intensity on the next topic is electric dipole. I am going to do. What is electric dipole? What is electric dipole? Two equal and opposite charges. Okay, equal and opposite charges separated by certain distance. Equal and opposite charge. Equal and opposite charges separated by certain small distance, certain small distance is called as electric dipole. What is electric dipole? Electric dipole, it is the arrangement of equal and opposite charges. Let us see here. This is the minus q charge and this is the plus q charge. These two equal and opposite charges separated by certain distance. The distance is the 2L. Okay, from center to first charge distance is my L, second charge distance is L. This is called as electric dipole. Dipole, two poles, two charges, that's all. Okay, now next one is the what is electric dipole moment? Electric dipole moment. Electric dipole moment is what? Electric dipole moment means, can anyone write the formula for the electric dipole moment in chart box? It is denoted with P. Okay, electric dipole moment means what? It is the product of magnitude of charge and the separation between the two charges. Magnitude of charge is what? Q. Okay, separation between the two charges is what? 2L. That is the electric dipole moment is a Q into 2L. Electric dipole moment is a vector. Electric dipole moment is a vector. Is a vector means it should have some direction. What is its direction? Okay, its direction is from minus q to plus q. Remember it. The direction is from minus q to plus q. This is the direction of the electric dipole moment. Electric dipole moment direction. Next, minus q to plus q. Dipole moment formula. What is the unit of the electric dipole moment? The unit charge into distance, coulomb meter. Coulomb meter. Okay, right. This is about the electric dipole moment. Next important topic I am going to explain, that is how to find out the electric field on the axial and equatorial line of dipole. Electric field on axial line of electric dipole. On axial line of electric dipole. This is a dipole. This is the minus q charge. This is A point. This is plus q. It is the B point. This is the center of the dipole. Okay, this is the center of the dipole. And at a distance r from the center of the dipole, I want to find out the electric field at the point P. Here I want to find out the electric field. Electric field due to the dipole on the axial line. This line is passing through the two charges. That is called as the dipole. Okay. Right now, axial line, dipole axial line. On the axial line at point P, I want to find out the electric field. For that, here electric field is there due to positive charge and due to the negative charge also. Due to positive charge, electric field is away from the positive charge, that is E plus Q. And due to the negative charge also at point P, electric field will be there. Due to the electric field towards negative charge, it will be there. Right? That is E Q2 minus Q charge. Net electric field I want to find out at point P. How to find out the net electric field? For that, you know this is L, right? This is L and this is also L. Then I want the, from this, if you want electric field due to plus q charge, E due to plus q charge I want. E due to plus q charge. What is the electric field due to plus q charge? Can you write electric field due to plus q charge? Electric field due to plus q charge formula is, you know, electric field due to point charge 1 by 4 pi epsilon naught into q by r square. What is q here? due to plus q charge I want. Q by q distance we have to take from point P. At point P, plus q charge, due to plus q charge electric field. Point P distance from electric, remember it, one thing, electric field due to plus q charge. Electric field due to plus q charge. Plus q charge distance you should take from point P. What is that BP from the figure? R square we have to take. R is BP square. Then from this figure, what is the BP? BP from the figure is, BP is nothing but this from the center. This is R. This is R. From the total R, you remove this part. You will get this part, right? This is for example C. CP minus CB gives BP. Is it right? Then we write as R minus L. Okay, R minus L is the BP. BP square. Understood this one. And electric field due to minus Q charge if you want. Then electric field due to minus Q charge, what we write? 1 by 4 pi epsilon naught into Q. We should not write minus here. Why we should not write? We have to use the vector addition here. Vectors only magnitude I am writing it here. Due to minus Q charge, minus Q distance you should take it point from point P. Okay, minus Q distance from point P is what? AP. AP square we have to write. A minus Q distance from point P. AP. At AP square you want, right? 1 by 4 pi epsilon naught into Q by AP is nothing but up to CP distance R. This C to A distance, right? AP we write as AC plus CP. Right? AC is L and CP is R. R plus L we should write. Okay, right. From these two, this R minus L is less. That's why E plus Q is more. Okay. The net electric field I want. Net electric field. How to find out the net electric field? Net electric field is the sum of these two. Okay. But we should subtract them. This E suffix plus Q minus E suffix minus Q we should write. Then here we write like this. That is 1 by 4 pi epsilon naught into Q by R minus L whole square minus 1 by 4 pi epsilon naught into Q by R plus L whole square we should write. And here we can common the net electric field intensity on the axial line. That's why we are writing E suffix A, that we can common the Q by 4 pi epsilon naught and we can simplify it, and then we will get as 1 by R minus L whole square minus 1 by R plus L whole square we will get. And now you simplify this after LCM, then we will get like this. That is 2 by 4 pi epsilon naught into, after simplification, you will get as 4RL by R square minus L square whole square you will get after LCM and simplification. This we can write like this. That is electric intensity on the axial line we write as 1 by 4 pi epsilon naught into 1 by 4 pi epsilon naught into this 2R we should write aside. 2R into 2 we write. In this one 2 and Q, here Q I am writing. Okay, remember it. Q I am writing. Here 4L I write as 2 into 2L. 2L we write. By R square minus L square whole square we should write. Okay, right. What I am doing it here, Q into 4RL is there. Here Q is there. 2R into 2, 2 into 2 again 4. 4RL we are writing, just we are rearranging the numerator. Then why we are writing the new rearranging that one? Q into 2L is P. Q into 2L is P. Dipole moment formula is Q into 2L. That's why we are writing here 1 by 4 pi epsilon naught into, here Q into 2L is P. P into 2R we write as 2PR by R square minus L square whole square we will get. This is the formula for the electric intensity on the axial line. Okay, right. This is the derivation. Okay, if you have any query, you write in the chat box. For example, if you want to continue this, in case of short dipole, how to write it? I'm going to erase this. If you have any query, write in the chat box. Is it clear, students? Any doubt? Right, clear. Thank you, Aditi. Next, I will continue. So, note. Okay. In case of short dipole, what we can write? In case of short dipole, what you got the final formula for the electric intensity on the axial line of dipole? Electric field intensity. Electric field intensity on axial line of dipole. On axial line of dipole, we got is 1 by 4 pi epsilon naught into 2 pr by r square minus L square whole square you got. This is the final formula, right? Electric field denoted with capital E. Remember, don't be confused. Electric field denoted with capital E. This 1 by 4 pi epsilon naught. This is epsilon naught. Now, in case of short dipole, in case of short dipole, short dipole means this is minus q charge. This is plus q charge. Okay, and at a distance something, right, from center at a distance r on the axial line, I want to find out the electric field, right? And this length is L, and this length is L. Dipole length is 2L. L plus L is 2L. Is it right? Now, dipole moment direction is what? What is the dipole moment direction? Right side na? Minus Q2 plus Q. Here, electric field intensity on the axial line, I want a direction. And short dipole means what? This length is less, very much less comparing with R. L is less than R. L can be neglected in the denominator in above formula. When you neglect the L, we will get like this 1 by 4 pi epsilon naught into 2pr by r square whole square minus L square. This L we can write 0 here. R square whole square you will get. R power 4 you will get. Finally, we will get one formula for the electric intensity. That is 1 by 4 pi epsilon naught into 2p by r cube we will get. This is the formula for the electric intensity on the axial line of dipole. What is the direction of this one? Remember it. Due to plus q charge right side is there. Due to minus q charge towards negative charge is there. Okay, minus q. But the net electric field due to both of them, S q effect is more. That's why the net electric field is right side will be. Intensity on the axial line is right side. Then electric field intensity on axial line of dipole. Electric field EA is a vector. Okay, electric field intensity on the axial line parallel to dipole moment. Okay, EA is parallel to dipole moment. Understood? Right. Let us go for the electric field intensity on the equatorial line. What is equatorial line? These are very important topics. Okay, and E on electric field on equatorial line of dipole. Electric field on equatorial line of dipole. Equatorial line of dipole. I want to find out the electric field intensity on the equatorial line of dipole. What is equatorial line? What is a dipole? This is minus q charge. This is minus q charge. And this is plus q charge. Okay, this point we can take as A point. And this point we take as B point. And this length from the center, left side length is L and the right side length is L. And this is a line. Okay, this is a line. It is passing to center of the dipole. The center of the dipole and perpendicular to axial line. Axial line is this one. This is the axial line. The line passing through the two charges. This is equatorial line. At point P, I want to find out the electric field. This is a point P. This is at a r distance from the electric field, from the center of the dipole. At here, I want to find out the electric field. For that, you should join the what, minus q charge with point P plus q charge also with point P. Okay, right. Due to minus q charge, what is the direction of the electric field? Due to minus q charge, electric field direction is towards the minus. Remember, you know that one. This is E due to minus q charge. And due to plus q charge at point P, electric field will be there. That is due away from the plus q. Okay, that this is E plus q. And net electric field I want. According to parallelogram, I have two electric fields. This is equatorial line. Okay, this black line is the equatorial line. On the equatorial line at a distance r, I want to find out the electric field. And then further purpose, what we are doing it here. Electric field due to dipole. Dipole has two charges. Due to minus q charge, due to plus q charge, we have to find out and we have to calculate the total. And this angle we can consider as theta, and this angle is also theta. Now we can classify the electric field into components. Further, what we have to do, according to mathematics, this is theta means this is also theta, and this is theta means this is also theta. Now we divide the E plus Q, okay, to E due to electric field, E due to positive charge, E due to plus Q charge, E due to plus Q charge. Can you write E due to plus Q charge? Formula is what? E due to plus Q charge. Okay. E due to plus q charge or the minus q charge, both are same. Okay, E due to plus q charge is plus q at point P. I want to find out the electric field due to plus q charge. Then for the purpose, what we have to do? Then we have to take the point P distance from plus q charge. That is 1 by 4 pi epsilon naught into q by this. Due to plus q charge, I want to find out the electric field at point P. Point P distance from plus q charge you should take BP. And the general formula is what for the electric field? 1 by 4 pi epsilon naught q by r square. R is what here? R is the distance of the charge from point P where you are finding the electric field. Right? Electric field due to plus q charge I want to find out. BP square you write 1 by 4 pi epsilon naught into. Then we can simplify later. BP square, if you want to write how to write the BP square from the Pythagoras principle. Okay. Similarly, electric field due to minus q charge, so we can find out. Don't write minus because we want using the vector additions. Then only we should write minus magnitude 1 by 4 pi epsilon naught into q by charge minus q charge. Magnitude is q. Its distance you should take from point P. That is AP square you should write. Okay. And then, but from figure, okay, from figure, if you write the BP square and AP square from the Pythagoras principle, if you want to write APC triangle or BPC triangle, BPC triangle, BP square equal to CP square plus PC square plus CB square, which is right R square plus L square. That means BP square equal to we write as R square plus L square. And if you want to write AP square from the APC triangle, AP square equal to also R square plus L square. That means we write here from this BP square equal to AP square, that is equal to R square plus L square we will get. That means BP square, AP square both are equal means E plus Q and E minus Q also equal. That means E plus Q equal to E minus Q. Why they are equal? Because BP, AP are equal means this formula will be same. Then we will get 1 by 4 pi epsilon naught into Q by BP square. But BP square, AP square both are same. That is equal to R square plus L square, right? This is equation 1. And next I want to find out the net electric field here. For the what I have to do, E plus Q classified into components. This said E plus Q. This said E plus Q cos theta you will get. And here this said E plus Q sin theta you will get. Why? E22 plus Q charge will be like this there. This is the direction of the E22 plus Q charge. You classify this E plus Q into components. E plus Q cos theta, E plus Q sin theta. E minus Q also classified into components. Then for the purpose what you have to do? He said E minus Q cos theta you will get. E suffix minus Q cos theta. This downward, this said E minus Q sin theta you will get. Okay, downward. What happens at here? E plus Q sin theta is upward. E minus Q sin theta is downward. They will cancel with each other. And E plus Q cos theta, left side. E minus Q cos theta also left side at point P. If you see this point P diagram, we are drawing it here. These two will be cancelled. E plus Q sin theta, E minus Q sin theta, because they are opposite direction. Because they are opposite direction, they will cancel with each other. When they will cancel with each other, what happens? What is the remaining electric field? Net electric field on the equatorial line. Net electric field on the equatorial line, you will get like this. Net electric field on the equatorial line. What you will get the net electric field? Net electric field is E on equatorial line. You have to add the both of them. E plus Q cos theta. E suffix plus Q, remember it. E plus Q cos theta. E suffix minus Q cos theta. But E minus Q equal to E plus Q. This is also E plus Q cos theta, E plus Q cos theta. We write as 2 E plus Q cos theta we write. Okay, right. Then E equatorial line is equal to, we will write like this. 2 into E plus Q formula is what? E cos theta, E cos theta, 2E cos theta will get. E plus Q formula is 1 by 4 pi epsilon naught into Q by R square plus L square you will get. Into cos theta formula from the figure we write. Cos theta equal adjacent side by hypotenuse we write. From the triangle, cos theta equal to adjacent side is L. Hypotenuse is what? Hypotenuse is the BP. Hypotenuse BP formula is what you will get from the figure. If you want, write the BP formula from the figure. Okay. BP is equal to, we write as under root of R square plus L square, right? BP square is R square plus L square. BP is under root R square plus L square, right? If you simplify this, Q into 2L in the denominator will be there. 1 by 4 pi epsilon naught into Q into 2L. Q is there, here 2 is there, here L there. Q into 2L is P by, we will get as R square plus L square. This R square plus L square whole power 1. This one is R square plus L square whole power 1 by 2. This same means powers we should add. Then you will get whole power 3 by 2. This is the electric intensity on the equatorial line. Okay, you take the screenshot and note it. Clear, students? Next, electric intensity on the equatorial line. What you got here? Electric intensity on the equatorial line. What you got? electric field on equatorial line of dipole. On equatorial line. On equatorial line of dipole. What you are getting? Electric field on the equatorial line of dipole. That is E on equatorial line. E suffix EQ we write. That formula is we got is 1 by 4 pi epsilon naught into P by R square plus L square whole power 3 by 2. This is the formula that we derived it here, right? This is the dipole, right? This is the minus Q charge and this is the plus Q charge. What is the direction of the dipole moment? Is the right side, minus Q2 plus Q. We want to find out the electric field from the center. This is the line passing through the center and perpendicular to the axial line. At this point, electric field on the equatorial line we find out. What is the direction of the electric field on the equatorial line? You got left side, right? Electric field intensity on the equatorial line we got as left side. That is anti-parallel. Okay, in case of short dipole, what happens? In case of short dipole, short dipole means length should be less than r. L can be neglected in above equation. If L neglected, then what happens to the E on equatorial line in above equation? 1 by 4 pi epsilon naught into P by this L divided 0 r square whole power 3 by 2. This 2 by 2 cancel. Will get as by cube r cube. Is it right? Okay. What you got E on axial line? E on axial line we got is E on axial line 2p by r cube we got. E on equatorial line p by r cube we got. Okay. That E on equatorial line direction you want. E on equatorial line is anti-parallel to dipole moment. Is it right? Anti-parallel to dipole moment. That means we write here like this: E equatorial line is anti-parallel to dipole moment. Is it right? Electric field is left side, dipole moment right side. Anti-parallel to dipole moment. This is about electric field intensity on the equatorial line of dipole. Understood, students? Now let us go for the next concept. That is very important topic. Net force and torque on electric dipole. Net force and torque on electric dipole in uniform electric field. Very important. How to find out the net force and torque on electric dipole in uniform electric field? Okay, that listen very carefully. This is the uniform electric field. Uniform electric field means field lines are parallel to each other. This is the uniform electric field. Here I am placing some dipole here. This is minus Q charge. And this is the plus Q charge. The dipole moment is minus Q2 plus Q. This is the P bar direction. And electric field is right side. Electric field is right side. These lines. This angle we can take as theta. This angle between the E bar and P bar. Okay. E bar is right side. P bar is left side. And now this length is called as this length is 2L minus Q2 plus Q distance. Okay, and this we can take as A. This point is B. We draw a perpendicular line at here. On plus q charge, the electric field force will apply. If the electric field is right side, means this side of some positive charged plate we will keep. This side negative charged plate we will keep. And electric field direction away from positive charge and towards negative charge. This plus repels the plus. That's why on this force will be right side will be there. Force on plus q is right side. That value is E into q. Force on minus q charge is left side because this plus attracts the minus. Force on minus q charge is also same, that is E into q only. Right? Then that means what is the net force on this? Okay, force on plus q charge in electric field. Force on plus q charge is EQ. Force on minus q charge is also EQ, but they are in opposite direction. Force on minus q charge is also EQ, but they are in opposite direction. Okay, that's why the net force on dipole. Net force on dipole. Okay, net force on dipole is EQ plus minus EQ. Why we are writing the minus? Because they are in opposite direction. There is no net force. Net force is not there. Then what about the torque? Equal and opposite forces constitute the torque at here. For that we have to draw a rectangle here, a triangle here. Okay, and this is A, this is B, this we can take as C. And then torque formula is what? What is the torque formula? Equal and opposite forces constitute the torque. Torque formula is force into perpendicular distance. Force formula is what at here? EQ. And perpendicular distance formula is what? One force is this side. Force is EQ. Force is EQ. Same force. Perpendicular distance between the forces. Two forces are acting here. One is this side and other is this side. Due to equal and opposite forces, it will rotate. And then what happens at here? Equal and opposite force. One force is this side, one force is this side. The perpendicular distance, if you want to know, this is the perpendicular distance. For example, this is F1. Okay. For example, this is F1 and this is F2. There are two forces are acting. Perpendicular distance between them means this will become the perpendicular distance. Right? This is perpendicular distance. From the figure, perpendicular distance between the forces is BC. From the figure, the perpendicular distance is BC. Because once this is the perpendicular, right? And this is the perpendicular. And now this side one force is there, this side one force is there. BC is the perpendicular distance. EQ into BC we should write. But from the figure, how to write the BC? But from this will become the R perpendicular. Okay, we can keep it as R perpendicular only. No need of BC, right? Or from triangle ABC we write. What we write from triangle ABC? Sin theta we write. Opposite side by adjacent side. BC by opposite side by hypotenuse. AB. What is BC? R perpendicular. What is AB? AB is the 2L. AB is the dipole length minus Q2 plus Q distance. Then from this R perpendicular, if you write 2L sin theta, we will get. This we substitute in above equation. Okay, this is equation 1, equation 2. So what we have to do it here? Equation 2 substituted in 1. In equation 1. Then what you will get the torque? Torque is equal to, we will get is EQ into R perpendicular is 2L sin theta. But what is Q into 2L? Q into 2L is P. EP sin theta we write. Then finally we write the torque formula as PE sin theta. PE sin theta. This is the derivation for the torque. And net force. Net force is 0. Why the net force is 0? Because of equal and opposite forces. Net torque formula is this one. This we can write in the vector form also. Tau bar is equal to P bar cross E bar we can write. P bar cross E bar we can write. This is the torque formula, right? Understood, students? This is the torque formula. I'm going to erase this. What you got the torque formula? Okay. Torque formula we got is PE sin theta. Torque formula, torque on dipole formula is torque on electric dipole formula we got is PE sin theta. What is P in this? P is the Q into 2L. It is the dipole moment. Dipole moment. What is 2L? Dipole length. What is Q? Charge. E is the electric field. E is the electric field intensity. What is theta? Theta is angle between P bar and E bar. Angle between the P bar and E bar. Dipole moment and electric field. Next, when the torque will become maximum and when torque will become minimum. Case 1. If theta is 90 degree, then the torque will become maximum. Okay, PE sin 90, then PE you will get, that is a maximum torque. Torque will become maximum if theta is 90. If theta is 0, then what happens to torque? If theta is 0, then we write as tau is equal to PE sin 0 we should write. Sin 0 value is 0, that's why we will get as 0. This is the torque will become minimum. When you will get the torque maximum, if this is a dipole moment is right side and electric field is upward. For example, electric field is like this there. Both are perpendicular to each other, E and P. Okay, if E and P are parallel to each other, P is right side and E is right side, then torque become 0. P right side means what? Minus Q plus Q, right, like this it will be there. This is minus Q plus Q. P is right side, you know that one from this minus Q2 plus Q. Electric field is also right side. For example, if you apply the electric field right side, here I am applying the electric field right side. That means now electric field and momentum, dipole moment are along same direction. Then the torque will become minimum. Okay, let us go for the next topic. Next topic is also very important. That is work done to rotate a dipole. Work done to rotate a dipole from theta naught angle to theta. Or this question they will also ask like this: potential energy of electric dipole in uniform electric field. That very important topic. Many times it is repeated in the board exam. For example, this is a dipole. Okay, minus Q charge and plus Q charge. This is the electric field direction. Okay. Now the dipole moment direction is what? Minus Q2 plus Q. Dipole moment direction. This P and E are parallel to each other right here. P and E are at there is certain angle. That angle we can take as theta. P is this side and E is this side. There is some angle. Then when the dipole is placed in the electric field, on the dipole torque will act. Due to the torque, it will rotates. It will rotates like this. When it rotates, then its angle will be changes. For example, the final angle is like this one. This is the final position. Then the final angle we can take as theta, and initial angle we can take as theta naught. Then what is the work done to rotate the dipole from theta naught angle to theta? This is our question. We want to rotate a dipole from theta naught angle to theta, right? Then for that work done formula is there. Okay, that work done will store in the form of potential energy also. Work done formula is integration tau d theta. Actually, work done formula is force into displacement. Force here for the rotating work done, force is replaced with the torque. Displacement is the angular displacement. Okay, right. Torque formula we know already, P is sin theta into d theta, theta naught to theta. Then P we can write to a side. Integration sin theta d theta we will get. Integration sin theta we will get is minus cos theta. There is a formula. And the limits you should substitute next. What are the limits? Minus P we write outside. Minus we are writing outside it here. Cos theta. Limits are theta naught to theta. First substitute the in place of theta upper limit you should write. Minus P E into cos theta you will get. Minus in place of theta lower limit you should write. Right. Cos theta naught. Then work done we will get as minus PE into cos theta. So you should multiply with minus next. In the next step, you should multiply with minus. When you multiply with minus, you will get like this. E into P means dipole moment, E means electric field intensity. You multiply with minus cos theta plus cos theta naught you will get. That means you will get is cos theta naught minus cos theta you will get. This is the work done to rotate a dipole from theta naught angle to theta. Okay, right. Now, if initial angle is 90°, if theta naught is 90°, initial angle is 90°, then the work is equal to potential energy. Remember it. Work is equal to potential energy, right? That means that is U. When you substitute in above equation theta naught as 90°, if you substitute theta naught as 90°, you will get as PE into cos 90 minus cos theta. You will get cos 90 value is 0. 0 minus cos theta is minus cos theta. You will get finally as minus PE cos theta. Cos 90 is 0. 0 minus cos theta is minus cos theta. P into minus cos theta is minus PE cos theta. Then finally we are getting the potential energy formula is minus PE cos theta. This we can also write in vector form, that is minus P bar dot E bar. This is the potential energy formula. What is our heading? Work done to rotate a dipole from theta naught angle to theta. That we derived PE cos theta naught minus cos theta. Potential energy of dipole in uniform electric field, that we got is minus PE cos theta. P is the dipole moment, E is the electric field, and theta is the angle between the P and E. Okay, right. Now in this let us discuss a few cases. Within 2 minutes I will close the topic. Here only I will write, otherwise I will write here only. Right, the note. So when we say that the dipole is in stable equilibrium, condition for the stable equilibrium. First one is the condition for conditions for stable equilibrium. Stable equilibrium. Stable equilibrium means angle should be theta should be 0. Then the dipole minus q2 plus q. Dipole moment. Dipole moment is right side. Electric field is also right side. Then both are parallel means theta 0. Theta 0 means stable equilibrium. Okay. Next, what is the condition for the unstable equilibrium? Unstable equilibrium. Unstable equilibrium. Unstable equilibrium means theta 180 you will get. That means P left side, E right side should be there. There is some angle 180. Then here what happens to the potential energy? Potential energy is a minus PE cos 180. That you will get as PE, you will get. Potential energy is maximum at here. Here potential energy is minimum. Okay. These are the conditions for the stable and unstable equilibrium. Remaining we will discuss later. Thank you to all.